Now, what is advertised distance?
Well, as it says, is the cost between the next stop router and the destination.
What does that mean?
What does that mean? I am not 100% sure.
Okay, I'll draw a diagram. You need to tell me, with the help of diagram, I think you can manage. You can tell me the answer. Let's try, okay? Let's give it a try. I have router 1, router A, router B, and router 2. This is the diagram that I drew yesterday. Now the destination is 2222. From source 1111, the packet needs to go.
Yes, it says a lost connection and then it's coming back up.
Okay, I understand that. Now let's say the metric is 2 here, metric is 4 here, metric is 8 here, metric here is 6, metric here is 5, metric here is, okay, that's it. Now, what is the advertised distance to reach 22222 via router A? For router 1, to go to via router A, what is the advertised distance?
14.
Then what is the feasible distance? If advertised distance is 14, what is feasible distance? See the word advertise, distance, advertised. When RA advertises, what will be the metric? Tell me. When RA advertises, what will be the metric to reach 2222?
RA, it would be 6.
That is what called as advertised distance. For R1, it is coming as what? Advertisement. You agree?
Yes.
So advertised distance is the cost between the next hop and the destination. You understand now?
Yes.
For router 1, the next hop is router A. So it is the distance between, it is the metric between the next hop and the destination. Now tell me, what is the advertised distance via router B?
7.
Exactly. Now, what are the two FD values to reach 2222?
The FD going through router A is 14.
And then?
6 and 5, 11 and 2, 13.
Right. So which path is going to be elected path? The low cost path.
Look.
So which path is the successor path now?
Successor is the bottom part.
Very nice.
B.
So
B.
this is the successor path. Now my question is router path via router A qualified to be a feasible successor? Path via router A, is this path qualified to be the backup path?
Yes.
How?
Because I want to get my language right.
Because the advertised distance is less than the successor value, isn't it?
Yes.
That's why. So what you said is correct. So here you see, whatever you learned so far, this picture, this page is going to help you understand better. For outer C, to reach this destination, there are two neighbors. You can go via neighbor A, you can also go via neighbor B. So neighbor table will have neighbor information, Ethernet 0 and Ethernet 1. And then the advertised distance via A is 1000, which means this is 1000. A is advertising 1000. But the feasible distance is 2000, which means this is another 1000. That's how you can get 2000. So in topology table, what do you see? For every destination, you will see the feasible distance and the advertised distance and the neighbor via which you can go. So what is the metric here? 1500. What is the metric here? It's going to be 1000. Only then you will get 2500. So the lowest CFD is via router A. So router A route only will be available in the routing table. In the topology table, you also see the backup path because the advertised distance is less than the successor value. Any question on this page?
No. No question.
This is one of the main important page of today's class. Now, EIGRP uses 5 different packets. Hello packets are sent every 10 seconds. And no, I'm wrong. I'm not teaching OSPF, I'm teaching EIGRP. In EIGRP, hello packets are sent every 5 seconds. And if a neighbor is not sending hello for 15 seconds, the neighbor is going to be considered as dead. 5 and 15. We know the usage of hello packets. They are used to establish new neighbor as well as recover neighbor. Next, updates. Updates are sent whenever there is a new route got added. Updates, new changes. Not only new changes, means new change includes failure of link also. If a network goes down, when a link goes down, the network will go down. That also will go as update. Next, query. Query is when a router don't have, see the previous page, you have a feasible successor, a backup route. You have a backup. What if this backup route is not there? And this primary route goes down. The primary route gone down and there is no backup. What will happen, you know? The router will start querying, asking the neighbors about the route information. Hey, I lost the route. I lost the route. Anyone knows anything about this network? Such queries are sent when there is no backup route. For the query, someone will reply if they know. For all these three, acknowledgement is sent. You see one router is sending an update to other router. The other router will send immediately acknowledgement. Hey, thank you for the update. Likewise, query. One router is sending query. The other router will say, I received your query. That is an acknowledgement. And when some router sends the reply, the receiving router will send an acknowledgement. I got your reply. Thank you. For the hello packets, there is no acknowledgement because hello packets are always sent every 5 seconds. You cannot send acknowledgement for that. Hello packets don't have any acknowledgement. You see, router A comes up and says, hey, I'm A router. Means it will, A here it means the IP address of this interface. Let's say 10.0.0.1. Let's say I'm router 10.0.0.1. Who is on the link? And this neighbor table learns the neighbor 10.0.0.1. And when this sends the hello, it says, hey, I'm 10.0.0.2. And if it has got some routing information, it will also send us an update. Now 10.0.0.2 will be learned here. And the update will get updated in the topology table. Acknowledgement will be sent to the update, sent to B. And A also sends the update. B updates it in the topology table. After updating, it also sends an acknowledgement for the update. And that's how they both are fully converged. Dual algorithm will fill the routing table.
I have a question.
Yes, please. Question.
Go back up to number 2. Inside that hello, what exactly is sending that hello and what is sent in the update? What's the difference?
Yeah. See, in the hello packet, the information about this router is sent. B is sending, hey, I'm coming from this IP address. This is the subnet mask. And I belong to this EIGRP autonomous system number, let's say 100. Only that much. Whereas in the update, it will send the routing table, advertise distance, and so on. See, network informations are not shared in the hello packet. The routing information, the network information from the routing table is shared as an update. Hello packet is simply saying hello. That's all. I say, hey, I'm Jay, and you say, I'm Robert. This is not enough. Yeah, when you say I'm Robert, I know that I'm talking to Robert, but I don't know anything more than that. And you don't know anything more than Jay. Only name Jay, what is the use? I should say, hey, I'm Jay, I'm a trainer for networking. Then you understand, he's a trainer. Then anything related to that training, I'll ask you. That's an update. Hello packet is not enough to know about a person. You also need to know his background, his detail, his job. That is update. Likewise, for a router, we have routes. That's an update.
Understood.
Right. Next, EIGRP and IGRP both are Cisco protocol. In fact, IGRP is no more because EIGRP is a better version. It's a better version of IGRP. EIGRP is a better version of IGRP. Yes, EIGRP is a better version of IGRP. Now you got 5 metrics: bandwidth, delay, reliability, load, and MTU in IGRP. Even in EIGRP, you will see the same 5 metric. But what is the difference? Difference is IGRP is 32 bit of metric value, whereas IGRP is 24 bit. That is why they are saying to get EIGRP metric, you need to multiply by 256. Why? IGRP is only 24 bit. How many bits you need more to go to 32? 8 bits. So 8 to the power of 8 is 256. You got 8 bits lower in IGRP. So if you take IGRP, you need to multiply by 256. Only then you will get EIGRP metric. So that's the big difference. Otherwise, it's the same and same values: bandwidth, delay, reliability, load, and empty. Both EIGRP and IGRP follows this 5 metric components. And wait, before I talk about this, I want to go back, go here to this page. This is what I was talking about. IGRP metric bits are only 24. EIGRP is 32. So, if you want to know the metric of EIGRP, you need to multiply IGRP metric into 256. That will give you EIGRP metric. If you want to convert that into IGRP metric, then you divide. Divide by 256. Take the EIGRP metric, divide by 256. Again, this is all not really needed. Why? There is no more IGRP in the industry. It's removed from the routers. If you have some old router, you may not find EIGRP. In such case, what you can do is you can run IGRP and EIGRP in this router. IGRP, EIGRP. So the routes given by EIGRP will automatically get redistributed into IGRP. Why? Because both from same protocol, Cisco protocol, only the enhancement, so that division multiplication will happen automatically. You don't need to do any multiplication or division. As long as this autonomous system number is same on either side, they can send and receive the update, no problem. EIGRP can give its routes to IGRP, and IGRP can give its route to EIGRP. Now let's go back. So metric of EIGRP and IGRP is same: bandwidth, delay, reliability, load, and MTU. But the number of bits that are used to calculate the metric is not the same. EIGRP got 8 extra bits, 8 more bits than IGRP. So if you will see a metric of IGRP, to get EIGRP metric equivalent to that IGRP metric, you need to multiply by 256. And those things are not really necessary because the protocol EIGRP is nowhere seen anywhere, in any route. Now, what about the metric of EIGRP? Are we going to use all this 5? You see, we have bandwidth and delay, only 2. Even though we got 5 metric, only these 2 are considered. You see, metric is equal to slowest link's bandwidth plus sum of delay. Slowest link bandwidth plus sum of delay. If you see, K1 is 1, which is bandwidth. K2 is 0, which is load. K3 is 1, which is delay. All other are 0, reliability and MTU. Anything multiplied by 0 is 0. Anything multiplied by 0 is 0. So what you see here is load is multiplied by 0. So 0, this is 0. Load is multiplied by 0. And then reliability is multiplied by 0. MT is also multiplied by 0. Don't worry about this algorithm. This is too complicated, not necessary for us to know. All that you need to know is, even though we got 5 metric, only K1 and K3 are considered. All the rest are 0. K2 is 0. K2 is load. K5 for K4 is reliability. K5 is MTU. These 3 are not considered. Bandwidth and delay. Only these 2 are considered. Only K1 and K3 are considered. Metric is equal to slowest link bandwidth plus sum of delay. What does that mean? See, when someone is asking you for metric of EIGRP, this is what your answer need to be. Metric of EIGRP is equal to the slowest link bandwidth plus sum of delay. That's all. Or if you cannot remember slowest link, at least you need to say bandwidth and delay. Don't say all, you can say all these 5 also, but you should end saying among these 5, only 2 are considered by default, which is K1 and K3. K1 is bandwidth and K3 is delay. This number should not change. K3 means it is always delay. K5 means it is always MTU. What is K? Don't ask. It's simply some value they want to have. Someone will say oh, A1, A2, A3. Like us here K1, K2, K3. Now what does this mean? Slowest link mean what? Sum of delay means what? See this picture. For A to reach D, which is the slowest link in this path? This is the slowest link. Why? Because the bandwidth is only 64 kilobits per second. Whereas this is T1. T1 means 1500 kilobits. kilobits. So which is the slowest link? This is the slowest link. That is why going via B and C, the bandwidth is only 64. Slowest links bandwidth. Plus sum of delay, you need to add all this delay. 2000, 2000, 2000, 6000. Sorry, 2000, 2000, 2000, 6000. If you go this way, 2000, 2000, 2000, 2000, 8000. Bandwidth is slowest link, all the same speed. That's all you need to know. You don't need to worry about tenths of microsecond, 10 to the power of 7, blah, blah, blah. Not necessary. If someone is asking what is the metric of EIGRP, metric of EIGRP is slowest link bandwidth plus sum of delay. Yeah. Any questions so far?
No, sir.
All right, thank you. So in this chapter, what you learned is about the most important features and terminologies of EIGRP. This had a lot of information. We covered this entire chapter in 3 days. It's a very big chapter actually. And this page is very important, and then this page is very important, and then this page is very important, right? And even this type packet type are also important. And then the metric is also important, right? So that's about first chapter. We have like this another 6 chapters.